light, reflection and refraction. What is the reflection and what is the refraction? How both are different? And how we are going to use this property of reflection in case of mirror and the property of refraction we are going to use in case of lens to the formation of the image. That all discussion we are going to see here. So one by one we'll see first what is reflection and its applications for the mirrors, like we have concave mirror, convex mirrors, how both mirrors are going to be different. And later when we'll talk about the refraction, so first we'll talk properties of the refraction, later we'll see that for the concave and convex lens. And we have mirror formulas, and we have lens formula, then we have magnification, then we have sign conventions. All these things we are going to see under this chapter. Okay, so any doubt is there, you write in the comment. And still, if you didn't subscribe our channel, please subscribe it so that time to time you'll get update about the video. Okay, so automatic that notification also will come, or sometimes when you will scroll YouTube, you'll get that lecture. Okay, so that separate lecture is there in the playlist. This is about the NCERT line by line, and another already playlist is there where we have key concepts in the quick revision. So line by line you can see, followed by that quick revision you can see. So let's see first about this reflection part. Okay, what are things is being discussed here that we are going to see. Okay, so now light. So light is what? It is the ray that we are getting from some source. Okay, so one source is required. If any object we are able to see what is happening, light is going to fall on that object, and that light after reflection or maybe after refraction, that depends, it is going to fall on our retina, then we are able to see. So that discussion about the human eyes will be in the another chapter. Okay, so for the some object we are able to get the shadow, so that is the opaque objects. Okay, so now when we have this opaque object, so it has tendency. Okay, so when light is going to fall on this, so the bending of the light will takes place. It is not going to walk in the straight line, it will bend. So that effect is known as the diffraction of light. Okay, later we'll talk more detail about reflection. So here light is being diffracted. So to understand the phenomena, so here some story is given about how they have done work with this. Okay, so finally we have about reflection of light. So when suppose we have some surface, okay, so now light is not able to pass to this surface. So at a point here we are taking one line which is perpendicular to this interface, that we call as the normal. क्या बोलते हैं इसको? Normal. अब क्या हुआ? Now one light is going to fall on this light. जो लाइट आया उसको क्या बोलते हैं? This light is called as, this ray is called as, क्या बोलते हैं? Incident. This is the incident ray, and it makes some angle theta. So theta is the incident angle. So अब इस पर जब normal के साथ at the point of the normal after this interaction क्या हुआ? Again is going to bouncing back in the same medium. जिधर जिस मीडियम में आया उसी मीडियम में वापस. So this angle is the angle of reflection. Or this ray is called as what we'll call reflected ray. Okay. So यहाँ पर आपके पास इंसिडेंट रे है, नॉर्मल है, रिफ्लेक्टेड रे है. So on the basis of this we have law of reflection. Law of reflection क्या बोलता? The angle of incident is equal to angle of reflection. So theta I is equal to theta R. दूसरा लॉ क्या है? दिस इंसिडेंट रे, reflected ray and normal, okay, that is all are in the same plane. Like we have xy plane hai, yz plane hai, so they are in any one plane. Plane is what here? Some surface, okay, all are in the same surface. So that is the reflection of the light. और ये दो लॉ, टू लॉज इंपॉर्टेंट है. एंगल ऑफ इंसिडेंट किसके बराबर है? एंगल ऑफ रिफ्लेक्शन के बराबर. और ये इंसिडेंट रे, रिफ्लेक्टेड रे, नॉर्मल, तीनों क्या है? एक ही प्लेन में है, ओके, सेम प्लेन में. सो अब क्या होता है इसमें? समटाइम्स कभी आपको वर्चुअल इमेज मिला. वर्चुअल इमेज मीन्स देयर इज नॉट रियल मीटिंग ऑफ दिस रिफ्लेक्शन. आफ्टर रिफ्लेक्शन दोज रेज आर नॉट गोइंग टू मीट इन रियल, ओके. सो and in case of if it is going to meet in real after reflection, then it will form the real image. Otherwise, it will have virtual image. So real image you can take on the screen. Virtual image we can't take on the screen. So in the day-to-day life हम लोग क्या यूज करते हैं? प्लेन मिरर यूज करते हैं. सो इन द प्लेन मिरर वी हैव क्या है? लेटरल शिफ्ट है. लेफ्ट राइट दिखाई पड़ता, राइट लेफ्ट दिखाई पड़ता. और इमेज क्या है? वर्चुअल है, इरेक्ट है. सो वर्चुअल इमेज को हम लोग स्क्रीन पर नहीं यूज कर सकते, ओके. एंड इरेक्ट, सो जैसा हम लोग का इमेज है सेम साइड दिखाई पड़ता, इन्वर्टेड नहीं दिखाई पड़ता. और size of the image is also equal to the object. So now if you move away from the plane mirror, you will feel that how your image is going to change. When you are going to close to the plane mirror, your how image is going to change. तो जितना हम लोग उससे दूर जाएंगे, इमेज भी उतना दूर बनेगा मिरर के पीछे, ओके. जितना ऑब्जेक्ट, सपोज फॉर एग्जांपल ये क्या है? प्लेन मिरर, ठीक है, प्लेन मिरर. तो अब इसमें ऑब्जेक्ट मान लीजिए दिस इज एट 1 मीटर. सो इमेज भी क्या होगा? 1 मीटर इसके पीछे बनेगा. यदि आप स्टैंडिंग हियर वेयर एट दिस सपोज या 50 सेंटीमीटर्स फ्रॉम दिस रेफरेंस ऑफ द प्लेन मिरर, तो ऑब्जेक्ट, तो इमेज किधर बनेगा? ये भी 50 सेंटीमीटर अवे बनेगा, ओके. सो दिस इज द ऑब्जेक्ट, दिस इज द इमेज, ऑब्जेक्ट इमेज. सो दिस इज द प्रॉपर्टी ऑफ द प्लेन मिरर. क्या है? इमेज का साइज, ऑब्जेक्ट का साइज सेम है. जितना दूर, सेम डिस्टेंस इन द बैक साइड आल्सो, एंड इट इज द laterally inverted. This is the plane mirror. Now we'll have different situations, okay. So generally if you see that like many places we have curved mirror. So that curved mirror is what? It is the spherical mirror. Sphere मालूम है? Sphere just like a ball is the sphere, okay. So that is the some portion of that sphere, that is the called as the curved mirror. अब मान लीजिए what we are, this is the sphere for example, okay. And if you cut from here, so this portion will act as the mirror. Again if you cut from here, so this person is also going to act as the mirror. So later, one by one, we'll see, okay, concave mirror and convex mirror. So here, the mirror, जिसका reflecting surface क्या है? Spherical है, okay, that is called as the spherical mirror. So concave mirror and convex mirror, that what we are going to see later, that is the concave. Cave means just like a gufa. Concave. So that reflecting surface is the like a cave. Okay, concave. Reflecting surface क्या है? Cave. Okay, is this one. Another is what? Convex. So that is the oval in the shape. That is about the reflecting surface. Okay, so ray is coming from this side here. So its name is the convex. ये क्या है? Concave. Cave. Okay. So now a spherical mirror here, we have two types, and these spherical mirrors are the part of the some spheres. So we'll have some radius of curvature, we'll have focus, and we have pole. All these things we are going to discuss here. So it has that spherical mirror having either curved inwards or outwards. Like in case of concave mirror, what we have curved is here inwards. Okay, here curved is what inwards. Whereas in case of convex mirrors, क्या है curved, क्या है outwards. Okay, that is important here. So on the basis of this, we have two different types. So the face towards the, so this having the part of the some sphere. So here what you see that face is toward the center of the sphere, that mirror will be called as the concave mirror. So this reflecting surface is what here? Concave. Okay. And if you try to make here, okay, it will be the part of the one sphere. So that's why it is called as the concave mirror. And another spherical mirror that having reflective surface is kya? It is the oval. Oval in the shape. Okay. And curve is what? It is the outwards. So that mirror what we call as convex mirror. Okay. Now it's on the basis of set, it should be clear. Concave क्या है? Reflecting surface क्या है? Cave की तरफ bend है inwards. Convex में क्या है? Outwards. Okay. That shape is oval. Like suppose for example, if you take the spoon. Okay. If you are keeping the spoon inverted one, है ना? It will keep the inverted spoon. So that will become what? Convex. If we keep the spoon, how we are eating in that way, then it will become the concave. Okay. So now, so that's why they're taking the example of the spoon that curved inwards. Okay. That is the concave curve outwards. That is also called as the bulged shape. The spoon bulges outwards. So bulge outwards is what here? Convex. Okay. So now it is important to understand the various parameter here. Okay. So what is the center here? So now this mirror, suppose we'll take this one. If you divide this one in two parts, so here we'll have middle point. Okay, that middle point will be called as the pole. Similarly here in the concave mirror also, the middle point is called as the pole. The center, so this is the center of the reflecting surface. So when we will divide actually in two parts, so it will be symmetrical around the pole. Okay, how much portion is the upside? That much portion will be on the downside. So that center of the reflecting surface क्या है? Pole. Pole क्या है? Center of reflecting surface. किसी चीज का center, बीच है ना? That is called as the pole. Okay. So this pole always lies where? On the mirror, and it is represented by the capital P. So till now we have seen कैसे रिकॉग्नाइज करेंगे ये कॉनकेव मिरर है एंड कैसे रिकॉग्नाइज करेंगे ये कॉन्वेक्स मिरर है एंड व्हाट इज द पोल. ओके. Now we'll have discussion about another parameters. So like suppose for example, we'll take any one mirror. So all mirrors are the what it is the part of the some sphere only. Okay. So that curvature, so that spherical part, that reflecting parts is the what it is the curvature. So that is the, so finally it is the part of the some sphere. So that center of that curvature is called here, that is the center of the curvature is represented here by the same as the center of the mirror. So that is represented by the C. So C is what? It is the point that is called as the center of curvature or it is the center of the sphere by which mirror is formed. Okay. जिस स्फेयर से मिरर बना है उसका समवेयर सेंटर विल बी देयर, एम राइट। स्फेयर को क्या है, सेंटर है, तो वही सेंटर को क्या बोला गया है, सेंटर ऑफ कर्वेचर्स। सो सेंटर ऑफ कर्वेचर, नाउ if you talk about two different mirrors, okay, so now this is the, for us it is the convex mirror. So in the convex mirror, what you are seeing, center of curvature will be where, in the, where, in the right side here, okay, somewhere here center of curvature will be there. Whereas, so this is the convex. So in case of convex mirror, center of curvature किधर है, behind the mirror, okay, it is not in front of the mirror, it is the behind the mirror. Whereas if we talk about the concave mirror, okay, so that polished surface is this one and reflecting surface is cave. So it has center of curvature in front, okay, this is the concave. क्या है, concave mirror है, center of curvature कहाँ है, front of the mirror, और इसमें क्या है, behind और back side of the mirror. So that things we have to keep in mind, okay. तो वो क्या है, center, जिस center से वो बना है. Now if you join that center of curvature, और center of curvature क्या है, mirror में line नहीं करता, okay, it just says either it is the behind or in front. Now जिस sphere से बना है, what will be, they have some radius, okay, so when we join the center of curvature and pole, that length is called as radius of curvature. जिस curvature का एक part है, and now if you join the center of curvature and pole, okay, that length is called as what, radius of curvature, which is denoted by capital R. So simply you can say क्या है, जिस sphere से mirror बना है उसका radius है, so that is called as center of curvature, okay. So that is the radius of curvature, and center of curvature is C, and radius of curvature is what, R. So जिस mirror, जिस sphere का part है, okay, उस sphere का जो radius है, that is called as the radius of curvature, और उस sphere का center what we call center of curvature. Now if you join the line center of curvature and pole, okay, so that is called as, also called as what, principal axis. So this line, when we have joined the center of curvature and pole, what we call, this one is called as principal axis, okay, the spelling is important, principal axis. So that principal axis is what, it will be normal to the mirror at poles, okay, at pole it will be normal, perpendicular to that, okay. So that is happening here. So now here you can understand much better with the help of this. So sometimes if you see that we are able to, later we'll see that by this, using the property of this reflection, now if we'll keep the paper at particular point, and after reflection all rays are going to pass through that point, then finally that paper will burn, okay. So that is the convergence of light takes place at that point. So that is the bright spot by the mirrors, okay. So that like in case of sunlight, so the rays which is coming from the infinity, sun is where, much far from us. So now if you are able to find the focus of that mirror and some piece of paper, if you keep on that focus, so finally after reflection, rays are going to pass through that point, and due to that it will burn. So convergence of light is going to help us, okay, to produce the heat. So since क्या हो रहा है वहां पर concentration of lights हो रहा है. So due to that, substance is able to get the ignition temperature. Okay. So what ignition temperature is what? Minimum temperature that is required. So now here, this is the concave mirror. So here you are seeing that ray is coming parallel to the principal axis. So this line is the principal axis, which is joined the center of curvature and pole. So between center and curvature and pole, we have middle point. That middle point is called as the focus, and it is represented by capital F. So the distance, क्या था distance यहाँ से पोल के बीच में? सेंटर ऑफ कर्वेचर टू पोल का डिस्टेंस क्या है? R. और इन बिटवीन क्या हो गया? दैट इज द फोकस रिप्रेजेंटेड बाय कैपिटल F, एंड द लेंथ, the distance from pole to focus is called as the focal length. So that is represented by a small f. What is this? Focal length. So finally, since it is in the center, in middle of this radius of curvature, so whether we can write r equal to 2f. So this is the important relation between radius of curvature and focus. है ना? तो focus focal length क्या है? फोकल लेंथ क्या है? हाफ ऑफ रेडियस ऑफ कर्वेचर. और यू कैन से दैट अनदर वे, रेडियस ऑफ कर्वेचर क्या है? 2 टाइम्स किसका है? फोकल लेंथ का. सो कैपिटल एफ इज द फोकस, स्मॉल एफ इज द फोकल लेंथ. ओके. सो दिस डिस्टेंस, that is the focal length between P and F. Okay, and it is also called as the, you can call here, that is the principal focus. Okay. So where we have front of mirror in case of concave mirror, and in case of convex mirror, it is the behind. So like here in case of convex, this is the convex mirror. So since क्या है इसका reflecting surface क्या है? Bulge in shape. It is the oval. Okay. So इसका pole is here and center of curvature. ये दोनों का distance क्या है? Capital R. Okay. And the distance between pole and focal length क्या है? Focal length, that is the F. So in case of convex mirror कहाँ है? It is the behind the mirror. Okay. So now here you understood that what is the center of curvature, what is the radius of curvature, and what is the principal focus. Okay. So in case of concave mirror, we have real meeting of light. But in convex, what we are seeing, we are projecting the light. Okay, the light is coming here, and after that it is being reflected back. अब इसको क्या कर रहे हैं हम लोग? प्रोजेक्ट कर रहे हैं. So after that it is going to appear that it is coming from the focus. So the point from where it is going to appear that it is coming is called as the focus. Or this is the incident angle, this is the reflected angle. So angle I equal to angle R. Similarly, in case of concave mirror also, this is the incident angle and this one is the reflected angle. So here also angle I equal to angle R. Okay. So these are the important discussion about this. Okay. So here what we have seen earlier, R equal to 2F, that discussion is done here. Now it is important how image formation takes place, है ना? Image कैसे बनता है spherical mirror से? So those points, pole, focus, radius of curvature, center of curvature, all these points are going to help us to understand the image formation by the spherical mirror. अब इमेज बनेगा, कैसा बनेगा? रियल बनेगा, वर्चुअल बनेगा, कहाँ पर बनेगा, व्हाट विल बी द पोजीशन, और इमेज का साइज क्या होगा? छोटा, बड़ा, डिमिनिश्ड, इक्वल इन साइज या लार्ज इन साइज. All these discussion are here in case of image formation. So for the image formation, before saying this, we need to know what is the ray diagram. Okay, that ray diagram is actually important to understand how this formation of the image takes place. What is the rule behind this? कैसे हम लोग उसको ड्रॉ करेंगे? एग्जाम में क्या आएगा? सिचुएशन दिया हुआ है, आपको रे ड्रॉ करना है और रे ड्रॉ करके दिखाना है इमेज का फॉर्मेशन कहाँ पर हो रहा है। ओके, सो इसका बेसिक रूल, फर्स्ट रूल क्या है? रे पैरेलल टू द प्रिंसिपल एक्सिस जो भी है, आफ्टर रिफ्लेक्शन क्या होगा? इट इज गोइंग टू पास थ्रू द फोकस। इन केस ऑफ कॉनकेव मिरर में क्या होगा? इट इज गोइंग टू पास थ्रू द फोकस। और इन केस ऑफ कॉन्वेक्स मिरर में क्या होगा? इट इज गोइंग टू अपीयर, okay, to diverge from the principal focus. Like here we have dotted line, ये क्या है? appear, रियल में नहीं आ रहा, लेकिन if जब dotted dotted इसको प्रोड्यूस करेंगे, so it will meet at focus, okay, so it is going to appear. Whereas concave में क्या होगा? फोकस से होके रियल में पास करेगा। तो रूल क्या है? जो भी रे प्रिंसिपल, दिस क्या है? प्रिंसिपल एक्सिस, दिस इज द प्रिंसिपल एक्सिस, द लाइन विच इज ज्वाइनिंग द सेंटर ऑफ कर्वेचर एंड पोल इज कॉल्ड एज द प्रिंसिपल एक्सिस। तो जो रे प्रिंसिपल एक्सिस के पैरेलल आएगा, आफ्टर रिफ्लेक्शन मिरर से फोकस होके पास करेगा कॉनकेव मिरर में। कॉन्वेक्स में क्या होगा? इट विल अपीयर दैट इट इज कमिंग फ्रॉम दैट। So this situation you can see, और ये इंसिडेंट रे है, so this angle with the normal is the incident angle and this is the reflected angle. So this normal is going to pass through the center of curvature. Similarly here in case of convex also, this is the incident angle, this is the reflected angle, and this is the normal which is going to pass through the center of curvature. This F is the principal focus here, and that is the behind the mirror, and it is concave mirror. This principal focus is in front of the mirror. Okay, so this is the first rule. Now second one is what? If incident ray is going to pass through the principal focus, so it will pass through the principal focus in which mirror? Concave mirror. Whereas in case of convex mirror, it's going to appear that it is going to direct it towards the principal focus. Okay. Then after reflection, it is going to become parallel to the principal axis. So this is the incident ray. Okay. ये क्या हुआ? इंसिडेंट रे फोकस होके पास कर रहा है, तो आफ्टर रिफ्लेक्शन क्या होगा? पैरेलल टू प्रिंसिपल एक्सिस, सो दिस इज द रिफ्लेक्टेड रे। आफ्टर रिफ्लेक्शन क्या हो गया? पैरेलल टू प्रिंसिपल फोकस, प्रिंसिपल एक्सिस, नॉट फोकस, दिस इज द प्रिंसिपल एक्सिस। सिमिलरली इन केस ऑफ कॉन्वेक्स, कॉन्वेक्स में क्या हो रहा? अगेन हियर दिस इज द इंसिडेंट रे, तो यहाँ पे इंसिडेंट रे क्या हो रहा? इट इज डायरेक्टेड टुवर्ड्स द फोकस। ओके, और यहाँ पर जब रिफ्लेक्शन हुआ, सो दिस रिफ्लेक्टेड रे क्या हुआ? इट इज द पैरेलल टू द इसका प्रिंसिपल एक्सिस, दिस इज द प्रिंसिपल एक्सिस। Okay, these two rules. First one was what? If it is coming parallel to the principal axis, after reflection it will pass through the focus, and here opposite of that, if ray is going to pass through the focus after reflection, it is going to be parallel to the principal axis. Okay. Now third one is, if ray is going to pass through the center of curvature, okay, then it will be reflected back on the same path. Whereas in case of convex mirror, it's going to appear that is reflected along the same path. So that is the difference here. So here you are seeing this is the incident ray and this is the reflected ray. Both are on the same path. Here also in case of convex, incident ray, reflected ray, both are on the same line. Okay. Now fourth one is about oblique incidence. Oblique incidence means it is going to strike the mirror at any angle apart from the 90 degree. Okay, so that ray is called as the incident obliquely. So in this, it will be reflected also obliquely. So now here, if you are saying that it is going to fall on the pole, then again reflected back. So same angle, angle I should be equal to angle R in case of concave mirror. Similarly, in case of convex mirror also, angle I should be equal to angle R. So this incident ray and reflected rays follow the law of reflection. Okay. Law of reflection is what? Incident angle should be equal to the reflected angle, and incident ray, reflected ray, and normal, all three are going to lie in the same plane. Okay. So now by using these four rules, now we can see the image formation here in case of mirror. So here we have, this is the given table for the concave mirror. Okay. So here it is important in case of concave mirror that what is the position. First one is the object position, then position of the image, then size of the image, then nature of the image. So this all, again we have ray diagram there, so it will be much clear. So here you can summarize, if object is where at infinity, so infinity पे है तो क्या होगा, rays is going to come parallel to the principal axis. So parallel to principal axis, तो reflection के बाद क्या होगा, it is going to pass through the focus. So all rays are going to pass through the focus. So image formation will take place at the focus, and it will be highly diminished point size, and it is the real and inverted. Concave mirror, all image is the real and inverted except one position when it is between the pole and focus. Okay. Remaining all nature is what? Real and inverted except when object lies between principal and focus. Now beyond the C. C is what? Center of curvatures. Then it is going to be between F and C. So now object is coming close to the mirror and image is moving away from the mirror. Earlier it was at F, now it is between F and C. Lattice is also diminished, real and inverted. Now it is at C, center of curvature. So image is at C, moving away from the mirror, and here it is equal in the size, same size. What is the object size? Same image size. दोनों का size क्या है? Same होगा. कब? जब object कहाँ पे है? Center of curvature. Next we have object further. क्या हुआ? Close आया. कहाँ पे है? Between C and F. तो image क्या हुआ? Beyond the C. And अब क्या हुआ? Enlarge. Okay. And real inverted. अब क्या पाया? F. F पर होगा तो कहाँ जाएगा? Infinity. Okay. And highly enlarged, real and inverted. But if it is between principal pole and principal focus, then it is behind the mirror, so it is the enlarged, but it is the virtual and erect. So only this position is the exceptional in case of concave mirror where we are virtual and erect. So these are the, now you'll see here image formation, whatever we have seen the different position there. So this is the position where object is at infinity. So object is at infinity. To draw the ray diagram, you have to take minimum 2 ray. Okay, so 4 conditions we have seen in the how to form the ray diagram. So here कम से कम 2 consider करना है. So when it is infinity, तो क्या हुआ? So all rays is going to become parallel to principal axis. So parallel to principal axis है. After reflection कहाँ जा रहा है? Going to pass through the focus. One ray diagram. Second, if it is going to pass through this center of curvature, it will be reflected back in the same path. So that is also taken here. So 2 ray diagram, 2 ray condition is taken here. So finally image is found where? At the focus. कहाँ पे बना image? Focus. This is the image. So it is very small, highly diminished. But it is happening due to real meeting. So that's why it is the real and inverted. और image formation कहाँ पे है? Focus पे. Now object is where? Beyond center of curvature. This is the beyond C. So now one ray is taken, that is the parallel to the principal axis. After reflection, it is going to pass through the focus. Okay. Another situation is taken here. If ray is going to pass through the center of curvature after reflection, again it will come through the same path. So finally, where these two rays meeting, it is meeting here at point A dash. So here formation of image takes place. It is the below the principal axis, so it is the inverted image, and due to real meeting, so it is the real inverted, और size क्या है, diminished है, smaller than the object size. Object size क्या है, AB. Image size क्या है, A dash, B dash. So a smaller than this. Okay, a smaller than object. And formation takes place where? What is the position? कहाँ बना? Between center of curvature and focus. Okay, so that all things is important. Position, nature. Next is the at center of curvature. Object is where? At center of curvature. So again, two concept. One is the rays taken parallel to the principal axis. After reflection, it is going to pass through the focus. Second one is taken here. Ray is going to pass through the focus, and after reflection, it becomes parallel to the principal axis. So finally, both are having real meeting at the point A dash here. Okay. So here you see that A, B equal to A dash and B dash. So here image is what? Formation takes place here due to real meeting. So it is a real, inverted, and size is same size as the object. Okay, up to this is okay. Any requirement is there, any doubt will be there, you write in the comment box. So what we are saying that object is moving towards the mirror, but image is moving away from the mirror. So now object is where? Between center of curvature and focus. This is the object. So one ray is taken that is parallel to the principal axis. After reflection, it is going to pass through the focus. Another is taken, one ray is going to pass through the center of curvature. And after reflection also, again, it is going to pass through the same path. Okay. So where you have real meeting at A dash. So this is the image. So it is the below the principal axis. So it is the inverted. It is the real meeting. So it is the real and inverted. And here you see that image become large. Okay, larger than the object. Next position is what? Object is where? At focus. This is the object. Object is where? At focus. So now at focus. So again, two rays taken. One is parallel to the principal axis. After reflection, it is going to pass through the focus. Another is again going to pass through the center of curvature. After reflection, also same path. So finally, it is going to meet at infinity. So object is what? Very large. Real, inverted, large. Very large. Okay. So another situation that is the exceptional. When object lies between where? Focus and principal axis. So now here we have concept of oblique incidence. Okay. So now this ray is going to incident obliquely at pole after reflection. So again, it is going to have path. So this angle I equal to angle R is always the law of reflection, and it is going to pass through the pins. That is the one ray is taken, which is going to pass through the center of curvature, and after reflection, again, it is going to pass through the center of curvature. So finally, what you are seeing, when it is the projected in the back of the mirror, then it is going to appear that it is meeting at point. So that's why it is the behind the mirrors, which is the virtual, and image is where? Above the principal axis. That's why it is the erect. Below the principal axis, inverted. Above means erect. Okay. So this is the image is large. So this condition is the exceptional in case of concave mirror. So now it is important the applications. Okay. What are the applications? They will ask you the questions. Okay. So MCQ questions also, or some real-time applications question also will be given. So concave mirrors applications. It is used in the torch, searchlight, and vehicle headlight to get the powerful parallel beam of light. So that bulb will be placed at focus, then we'll have more parallel beam of lights. And it is also used in the saving mirrors to see the larger image of the face, as well as dentist also use to see the teeth of the patients. Okay, so these are the applications here. So whenever we require large image, and that is the, like we have in case of searchlight, parallel beam of light, so concave mirrors are used in the saving mirrors also. Okay, so large concave mirrors are used to concentrate the sunlight to produce the heat in the solar furnace. So that will be used for the cooking purpose also. So that what is the aim, that all parallel beam of light after reflection, it should pass through the focus. Okay. So till now we have seen about concave mirrors. Now we are going to see about convex. So convex mirror will have virtual image, virtual and erect. So now we'll see the situation here. If object is at infinity, okay, so parallel beam of lights falling on this reflecting surface of this convex mirror, and after reflection, it is going to appear that it is coming from the focus. So image is what? Highly diminished point size, and it is the virtual, since it is real meeting doesn't takes place. So it is the what? It is the virtual and erect. क्या है? Virtual and erect. क्योंकि real meeting नहीं हो रहा. Okay. अब position क्या है? At focus and behind the mirror, nature, virtual and erect. Whereas in other situations, if it is anywhere between infinity and the pole, then formation of the image will take place between pole and focus. Here, between pole and focus, anywhere it will take place. And nature is what? Virtual and erect. Size is the diminished. So this is the happening in case of convex mirror. Always we have virtual and erect image, whereas in case of concave, we have only one position where object is placed between pole and focus. Then we have virtual image. I hope it is clear, okay, how image formation takes place. So this all you have to keep in mind, and with practice, it is important. Now we need to understand. So here we need to understand that what is use of convex. Use is very important. So it is used where? In the rear view of the in vehicles. Okay, that is the wing mirrors. So this large image is going to see as the small image. So it is fitted on the sides of the vehicles so that drivers can see the traffic behind. And for this safe driving, it is important. So it is again why it is beneficial. It is going to provide always erect image. Okay, so that is the important. So that wider field view are curved outwards. Okay, so that we can realize in the vehicles. So that drivers will be able to see that larger area. Okay, is okay. So this is the applications of convex mirrors and concave mirror. Both are important. You try to do all this problem. Okay. So next we have sign convection of reflection by spherical mirrors. So like it will be sign convection is more important when you are solving the problem. When object is placed where, whether this object, that is the object distance, will be positive or object distance will be negative. Similarly, image distance. So that object distance will write as the u. Image distance will write by a small v. And focal length is f. When it is positive, when it is negative. Object height as the h. Image height as the h dash. So when these parameters are going to be the positive or negative. Another is the radius of curvature. That also we are going to see here with the help of sign convention. So now here, if you see that Already you know about coordinates geometry in case of Cartesian coordinates. So if it is the origin, suppose, okay. So anything here on the axis is what? Positive. Anything above the principal. So this one is the principal axis for us, okay. Principal axis. So here anything is the right side of the origin is positive. Above the principal axis is positive, and left side of this origin is the negative. Okay. And below this principal axis, what? That is also negative. So that is going to help us in case of sign convention. So those discussion is written here. Okay. So better we can understand here in this diagram. Okay. So here you see that always object is where. So this is the given condition for the spherical mirrors. So this mirror is what? Concave mirror. Okay, this mirror is concave mirror since reflecting surface is what? Inwards, bended inwards. So object will be placed somewhere in the left side. So object will be, that object distance will be what? Negative. And object is placed where? At the principal axis, above the principal axis. That object height is going to be the positive. If formation of the image takes place below the principal axis, then h dash is what? Negative. And formation of image takes place here, front of the mirrors, then b is what here? Negative. So this pole is taken as the origin. Okay. And right side, when virtual image will be there, so that virtual image, then h dash is also positive. Okay. And b is also positive. So that virtual image takes place in the right side. So these are the that what we are going to consider when we are solving the problem. Okay. This is important. Now we have mirror formula here. So that mirror formula is going to give the relation between object distance, image distance, and focal length. So in this concave mirror, if you see that focal length will be what? Negative. It is where? In the left side. So principal focus is in the left side. Okay, so focal length will be the negative here. So now formula is 1 by V plus 1 by U equal to 1 by F. This formula is applicable for the concave as well as convex. So this is called as the mirror formula. So sometimes one parameter will not be given. That parameter you need to find. So we have 1 by V. V is what? Image distance. U is the object distance. F is the focal length. Another is the magnification. Image कितना बड़ा बना कितना छोटा, that will be decided by the magnification. So magnification क्या है? It is the ratio of height of the image and height of object. So that is written as m equal to h dash by h. It can also be given in terms of image, that is the object distance and image distance. So that is the what? Minus b by u. So for magnification, we have two formulas, h dash by h and minus b by u. This is the mirror formula. In case of mirror, this is magnifications. And mirror formula, what we have here? 1 by v plus 1 by u equal to 1 by f. So here it is the positive. Here in magnification, it is the negative. In the lens, you see that both are going to change. Okay. So this relation is going to help you to find the which type of the image is formed, what is the size of the image. Okay. Now many things you are able to decide here on the basis of height of the object will be positive since it is always above the principal axis, and the height of the image should be taken positive for the virtual image, it will be above the principal axis, and negative for the real image which will be below the principal axis. A negative sign in the value of the magnification, it will show that image is real. So if you get the negative sign, y means that object height will be positive, image height will be negative. So finally, magnification will have negative sign. So it will show that it is the real image. Whereas this positive sign will show that it is the virtual image, since height of the object also will be positive and image height also will be positive. So on the basis of m value, m is less than 0 means negative, you can say here. Okay, not greater equal to 0 will write better. If m is what? Negative, then which type of the image formation takes place? It is the real image formation takes place. Real inverted. Okay. If m is positive, then image is what? Virtual and erect. So that you see that in case of concave mirror, in only one case, we have virtual image when object is placed between the pole and focus. So now some problem you can solve here. See how they're asking. Okay, convex mirrors used by rear view on the automobile. So it is the convex. Okay, it has the radius of curvature. So convex, just convex. Just will make the image, it will be better. So it has a radius of curvature. So radius of curvature is where? Right side. So finally what will happen here? This R will be the positive value here. So R is the plus 3 meter. If bus is located 5 meter from the mirror, so bus will be where? This side. Object will be this side. So U is what? Negative. Minus 5 meter. Find the position, nature of the size of the image. So position means we have to find the V and we have to find the height of the image, and we have relation F equal to R upon 2. So focal length is obtained here. Finally, mirror formula, all values are substituted with sign consideration. So finally, you will get here V value. So V is what? 1.15. What is this showing? It is the positive means image is what? Virtual. You know already it is the convex mirror. Convex mirror always having virtual image. So it is the right behind the mirror, and it is the back of the mirror 1.1 meter, and magnifications h dash by h, another formula minus b by u. So finally it is the positive, so it shows that it is the virtual and erect, and magnification is less than 1, so it is smaller in size by the factor 0.23. Like this you can see this some problem. Okay, so and try to solve. In the next lecture we are going to see about refraction of light. So here you have seen what is the reflection, what is the spherical mirror, and the parameters in the spherical mirrors: radius of curvature, focus, focal length, center of curvature, pole. All this discussion we have, and how we'll consider the sign, how different image formation takes place, and what is the positions, nature, and we have mirror formula, that is 1 by V plus 1 by U equal to 1 by F. And in case of magnification, we have M equal to H dash by H. In terms of image and object distance, it is minus B by U. Okay, so any doubt is there, you write in the comment box. Thank you very much.